Our second tutorial here is how to do the analysis section of this lab report. So to do this, the first thing that we need to do is write analysis in all caps underlined. The first thing in our analysis that it asks for us to do is to calculate the slope of each graph and show your work. You have already done that on the graph part, so we can just go ahead and check that off. The next thing that it's going to ask us to do is identify the mystery element based on information from your pre-lab. So if we go back to this work that I did in the last one, my fake mystery element had a density of 0.113 grams per milliliter. If we look back at our pre-lab, we would compare that to the known values of these things here. So whichever one of these is closest to 0.113 is what I would put for what I think it is. So back to our analysis, this part should be in sentences. So we would put, mystery metal X is likely, we'll say aluminum. I don't even really know what the measurements are for these. Aluminum and mystery Z is 10. The next thing that it asks for us to do on our checklist, so that will take care of this, identify the mystery element based on information from your pre-lab. The next thing it says is that you should give scientific data to support your predictions. In order to do that, over here we would say my calculated density for metal X was 0.113 grams per milliliter, and the density for aluminum is closest at whatever that is. We'll pretend it's 7.096 for now. Same thing for your second mystery metal. So we'll continue on giving those numbers, and this is grams per milliliter. Continue on giving those numbers for the second metal. The next thing, so we've done this. The next thing that we need to do is calculate percent error for each mystery item and show our work. I'll show you how to do that now. So to do this on your lab report, you can say mystery X and we thought that it was aluminum. We're going to pretend that it was actually aluminum. So we take the measured value minus the actual divided by the actual, and then we'll take this whole thing and multiply that by 100. So in the fake case of this data, we would take, I said the measured value was 0.113 minus the actual, which is 7.096. This whole thing right here, we divide by 7.096. If I were to plug this whole thing in my calculator times 100, I get 98, negative 98.4%. Our percent error always needs to be a positive value, so we do what's called the absolute value of that, and we just make it positive. So for mystery X, I have 98.4% error. You'll do the same thing for mystery Y, or whatever number you had, and you'll calculate out that whole percent error right here. that takes care of this checkbox. The next thing it says identify errors that may contribute to inaccurate results, explains how errors affected data. So on this part, you're writing in sentences. You're going to discuss errors that happened in the lab that contribute to my 98% error or your whatever percent error that you got, and you'll explain how those errors affect your data. You should at least explain one or two different errors. And then this last part will go in sentences right after that, proposes solutions to errors and discusses changes for next time. That's going to be how you can fix the errors that you just had before. So all of that is going to go right down here. And then the last thing you need is a conclusion. Your conclusion should address these 2 or 3 different things. What did you learn? What other properties can be used to identify substances? So in addition to density, what other context clues or clues could you have used to help you identify these substances? And then what properties would be best for identifying substances and worse? So of these other properties that you might be thinking of, which ones would work the best and which ones would work the worst? Thank you very much for watching. Have a wonderful day.